Good morning, this is Christina Long and this is the Science 411. Today's video is going to just be a short tutorial on creating ice charts for equilibrium equations. There's a lot to do with this particular topic, and it's not just a 5-minute video, it's more of a 30-minute video, but we're going to break it down into pieces. So, ice charts. It can sound scary. Sometimes people call it a rice chart, but we'll talk about ice chart. And the term ice stands for your initial amount given in the problem. C stands for change in your amount, and remember, anytime you've got a change, that's just delta. And then you've got E, which is the amount at equilibrium. Okay. So, we've talked a little bit about what the ice chart is. Now we need to talk about how to fill it in. So in this particular problem, you've got 3 moles of N2 and 1 mole of H2 are initially in a chamber, and when allowed to reach equilibrium, 6.663 moles of H2 remain, and it's asking you to find the Kc value. Now, one thing I did not put in here that's exceptionally important is that the container is a 1 liter container, and that is huge. It's not always going to be 1 liter, but in this particular case I'm putting it as that just to make it a little bit easier. So if you notice, you've got 3 moles of N2, 1 mole of H2, and then 0.663 mole of H2, and then you've got the volume of the container. And if you remember, when you're talking about important things dealing with moles and liters, that is the calculation for molarity. So it's going to be mole over liter. And now hopefully you can see why I would want your container to be 1 liter rather than something else for this point, because it makes it a little bit easier to deal with. So at this point, you're next left with trying to figure out what your molarity is. So you've got moles of N2, and you've got 3 moles of N2 over 1 liter, so you've got 3 molar N2, and then you've got your 1 mole of H2 divided by your 1 liter, and again it's obviously going to be 1 molar, and then along the same lines you've got your 0.663 moles of H2, and that's your equilibrium amount, but your 0.663 mole over your 1 liter, so now you've got 0.663 molar. So you've got your molarity set up, and now you need to see what the heck you're going to be doing with it in the actual ice chart. So now this is how an ice chart is going to be set up. Notice that you've got your reaction up top, and then you've got the ICE along the left-hand column there. And you've got your balanced equation, and this is why sometimes people call it a rice chart instead of an ice chart. Rice for the reaction, initial, change, and equilibrium. I'm just going to use ice for initial, change, and equilibrium, if that's alright with you guys. So let's go ahead and fill in some information that we found. In the previous slide from the equation, or from the reaction, it's asking you, or it's giving you the number of moles and the size of the container, which is in liters. So we used moles divided by liters to find molarity. And initially we found that you've got 3 molar for N2, and you have 1 molar for H2. And then you found the equilibrium. At equilibrium, once everything's done, you found that you had 0.663 molar of H2. So we've got 9 boxes, only 3 of them have information. So there are a couple of things that we can do, especially on that initial part. I'm not going to give you super hard equilibrium problems. This one is going to be one of your easier ones. So when you look at it, you've got these reactants there, and the reactants are ready to go, but the reaction hasn't started yet. And since the reaction hasn't started yet, you can make the assumption that there is no product made yet because it hasn't begun. Okay? So that's going to be your first thing. Your next thing is going to be this. You're going to have to look at your coefficients here, because those coefficients play a role in the change portion. And it's going to be important that you realize which direction the reaction is going. And in this reaction, it's going to be moving from the left to the right. So when I look at my change, I'm going to put a plus x because it's just a plus 1. There's no coefficient, so it's just a 1. And then on the next one for H2, I'm going to put, it shouldn't be plus, sorry, it should be minus. It's gonna change by a factor of x. And then for my H2, it's going to change by a factor of 3x. That means that my reactants are actually getting used up, and it's actually creating a product, so which that means that my change on my product side should be a plus 2x. So that's cool. I've got at least something there. My next step is going to be finding my x. I've got to go ahead and find my x. Well, the only place that I have enough information to find my x is in this particular column. And so what I'm going to end up doing is I'm going to say, all right, I've got 1 molar, or 1 minus 3x gives me my 0.663. So the first thing I'm going to do is I'm going to subtract 1 minus 663, and when I do that, I'm going to get 0.337. So my change, my 3x, is equal to 0.337. But I don't want to know what 3x is, I want to know what x is. So I'm going to divide each side by 3, and that gives me an x value of 0.112. And that's my x, and that's worth remembering. Alright, so now I can start doing some stuff. So if I've got 3 molar minus 1x, well, then it's going to be, the math there is 3 minus 0.112, and when I put that in the calculator, it's going to be 2.888, and I'm going to go 3 places past the decimal today because, well, that's what we started with. Alright, so we already know what 3x equals, and that's going to be that 0.337. So all we have to do is just put the 1 minus 0.337 because that's what we knew. That's how we found it. And then I've got to get to my NH3. And so now instead of subtracting, now I'm going to add. So it's going to be 0 plus 0.112 times 2. So let's go ahead and do that. And when I do that, it's going to be a plus 0.224. 0 plus 0.224 is going to be 0.224. So that's going to give me my initial numbers. My ice chart at this point is finished. Alright, that's not the answer to my actual problem. Instead now, I've got to take the values here and apply them here into, remember the KC value? The KC value expressions, writing expressions is one of the first things that we did in this unit. I have to use all of those values to find my actual KC value now. So in this slide, I just reminded you of your equation, and then I pulled over the equilibrium values. Here's how you're going to finish this up. You've got to write an expression for this equation. And so in doing that, we would say, okay, I've got NH3 squared over into times H2 cubed. So the next thing is, because now you've got these values, before you didn't, so now you're going to have 0.224 squared over that 2.8888 times 0.663 cubed. So when I fill in everything and then I run my numbers, and you guys know me, I'm going to do it the easiest way possible. So I took my stuff on the numerator and I multiplied that, and I got 0.05, and then I took everything in the denominator and followed the order of operations and then multiplied everything together to get 0.804, and then I went ahead and divided that. My KC value for this equation is going to be 0.062. And that's the actual answer for all of that stuff for the ice chart. And this again is one of your easier examples. I would suggest that you watch this through a couple of times. I would not go and start looking around the internet to try and watch more, because the examples that you're going to see are going to be more complicated. We will work up to more complicated stuff on Wednesday, and should you have any questions, please leave the questions in the discussion board and check in with me to make sure that I know you've watched it. I hope you guys have a good day. Make good choices, clean your room. Talk to you next time. Bye.